Hey folks, in today's video we are going to dissect the implementation used by Babel to transform JSX. The main idea is to break it down step by step to understand how it works and compare it to my implementation. Without further ado, let's get to it. Here I'm the file create plugin that you can find in the Babel repository. The path is package babel-plugin-transform-react-jsx source create plugin.ts. Let's give a look to the visitor object. The plugin operates by targeting 5 elements: JSX namespace name, JSX spread child, program, JSX fragment, JSX element, and JSX attribute. Interestingly enough, they do not target JSX text as I did in my implementation, but they have two or three other elements that I did not target. Those two first one and the last one. So let's see the purpose of each one. The first one acts as a safeguard against namespace JSX names. Actually, React JSX does not support namespace. So if it encounters something like, let me show you what is a namespace is. Let me put it here. I will put it just here. Something like this. It throws an error because JSX does not support it. So it's a defensive code against invalid JSX. The same here. This function prevents the use of spread children in JSX, which is not allowed. It's not a valid syntax. Let me show you. Actually, spreading children like this is not allowed in JSX. So here we have some safeguards against invalid JSX. Well, program has more to it. First, it defines some variables with some annotations. If you check this one, as you can see here, there is some JSX annotation, regex, and then it processes comment. Actually, what's happening, it looks for JSX configuration annotations that allow developers to configure the JSX transformation per file. It determines the runtime, classic or automatic. It defines which function call should be used, either create element or the new JSXs or JSX. It set the import source, process pragma and pragma frag options. Actually, this program function mainly defines the environment of the processing or the environment of the JSX file. But there is no transformation happening here. Let's check JSX fragment now. This function is responsible for transforming, of course, the JSX fragments. The heavy lifting here is done by the function build JSX fragments call. And after the transformation, it replaces the original node. Interesting note here, it uses this helper, inherits from a Babel type. Its purpose is to copy over certain metadata and properties from one AST to another. It's needed to preserve important information during this transformation process. Well, JSX element is similar to a JSX fragment in sense it delegates the heavy lifting to another function called build JSX elements call, And finally, it replaced the node using the same helper. I don't focus on the transformation to a create element, as I'm interested only in the last syntax using the new function calls using JSX or JSXs. And the last piece to this puzzle is the JSX attribute. Actually, it just makes sure when using a JSX element as attribute, it's properly wrapped in a JSX expression container. In simple words, actually, if there is a component with a property like this that is not wrapped in brackets, you just transform it to make it inside bracket like this. So no heavy lifting here. So the real meat of our transformation happens actually in two key functions that are build JSX fragment call and build JSX element call. So let's check them out. Let's go directly to this one. It's the most important one. So here, as you can see, it starts with getting the opening element of our JSX and initialize an array with this function call that seems to get the tag name. Here you get the opening path from opening element, and here it initializes an array with this get tag that gives, I guess, the tag name. If you see my implementation, for example, we do something similar, but not exactly the same. We get the tag name. Well, here I access it directly from the IST, but I guess there is more to it. I guess this is naive. They need to do some processing maybe. But anyways, the idea is the same. Then they initialize this attribute array, and this weird object extracted using object.create null. Actually, this object.create creates an object without any prototype. If you just put an object like this, well, I can't write here, a simple object like this, actually it will have a prototype, but using this helper create and passing null to it as argument creates an object without any prototype. And here it processes the attributes. As you can see, it checks for special attributes like keys, for example here, or source and self, that they are used in development mode, and they are processed separately in this extracted object. Otherwise, the attribute is pushed into this array, attribute array. Step 3 is build the children property using this helper from Babel type React build children. Let's check the code of this build children. If we go here, actually in Babel types, source, builders, React, build children. The code is quite simple, I would say. It loops over the children, check if it's JSX text, it does some cleaning, and then checks if it's an expression container and grab the value from expression property. I believe I did something similar in my implementation. And if it's empty, you just continue and push the child into this element array that is returned at the end. The cleaning actually happens here. It has more to it. It handles, I believe, leading space, broken lines, and stuff like that. Well, in my naive implementation, what I did, I just checked if it's a line break, I will remove the node. Otherwise, I keep the text as it is. Well, here it's more, I would say, more sophisticated and handles all the cases and edge cases. Actually, this cleaning is necessary because it has to handle the mismatch between how JSX is typically written in our code editor and how it's expected to be rendered in the HTML eventually. And the fourth step here is preparing the argument needed for the function call. If there is attribute, I mean pups and children, we call this function that does the heavy lifting. If not, actually we cannot have an empty property, so we give it an array. So let's check this function out. It's here. First, it builds an array of props using a reducer. Then it pushes the children property and creates an object expression. If we check this accumulated attribute, the reducer used here, how it works, it checks if it's a spread. A spread is like this one, but for props. I guess it has some specific syntax. So here it addresses this the value in the AST to grab the properties and put them into the array and returns this array. If it's not a spread, it's just one property, then it uses this convert attribute value that actually just handle JSX expression container. As we said in the previous video, when a JSX element or node is an expression container, the value lives in the property expression. So we need to grab it here instead of the node. So this is what is doing this function, convert attribute value. It just handles expression containers. Here we have a safeguard actually. If we have a key property but without a value, it throws an error, which is an invalid syntax. And once we reach this level, actually there is some specific processing for string literals. It says the raw JSX should not be used from string literal because it needs to be escaped. Well, I don't know if this mandatory or just to have a safe code against code injection. In my case, I do not handle it like this, so I hope it will work. I know my implementation is naive, but the main idea is processing string literals as well. There is something that I'm not sure about. They handle also namespaces here, even if it's not a valid syntax, so I don't know why. But anyways, I will focus on the other part of the code. So here they create the name, either it's an identifier or string literal, and create the object's property within the value and the name. And pretty much it. Well, it's somehow similar to my implementation in sense there is similar steps. I build props, build children, build function argument. Well, I get my identifier from this function. It's not the case here, I believe, because they call it directly. Let me check, where is it? Here they call the function, and they check here if it's if children has one element, they call JSX, otherwise they call JSXs. So this call function, what it does is just call the helper call expression, the same one I'm using here. Here they get the identifier using their helper, and the arguments that actually have let me see, yeah, here args actually is this one that has the attribute with children and the tag name that was put here at the beginning. So that's pretty much it. For arguments is somehow similar. If we go back to the JSX fragment, it calls this build JSX fragment call, and here, well, the args start with the tag name, which is a fragment. Well, in my case, I put it manually here as identifier. They don't process pops because a fragment does not have pops. So as I said in my previous video, I did it as defensive case to use the same function. And I was thinking in case there is a key, because fragments can have a key, but interestingly enough, it seems they do not handle it here. Interesting. Maybe I should check this information and see if it's accurate or not. Anyways, and then they build children using the same helper, and either there is children or not. If no children, just an empty array. If yes, build children property, and children property, it checks if there is just one child. If you remember, if there is one child, we don't use an array, so we get the node directly. If there is more than one child, then we create an array expression, and then we create the object property. That's pretty much it. Now I have a good idea on how Babel process JSX and transform it to pure JavaScript. So now my next step would be to test my code against React. So take this output from this little application and put it in an HTML file and grab a React and see if it's working or not. And that would be the subject of the next video. So thanks for watching and see you in the next one.